total of 12 electrons to play with. So to make it happy with 8, I have to have some double or triple bonds so it can be happy with 8. However, since 8 plus 8 is 16 and I have 12, I know they only have to be a double bond. So by looking at this, you see how this will go up there, and this will form a double bond there, and you leave your lone pairs out here, like that. So, how many bonded pairs do I have? I have 1, 2, because you have 2 bonding pairs in a double bond. So I have 2 bonded pairs. How many unbonded pairs I have? 1, 2, 1, 2. So I have a total of 2 plus 2, which is 4 unbonded pairs. The shape, you see how this is linear? Just like up here. So it is linear. Is it polar or non-polar? The oxygen pulls the electrons that way. This oxygen pulls it this way. They cancel each other out. So it is non-polar. Okay, CH3F. Okay. On here you start with C in the middle. So you always want to draw your C in the middle. Actually, you're getting this right. You draw your C in the middle. 1, 2, 3, 4. Over here is the H. Over here is an H. Over here is an H. Right now it doesn't matter which one you put it on. Hydrogen is happy because it has its 2 electrons on each hydrogen. Then fluorine's down here. 1, 2, 3, 4, 5, 6, 7. Since it has 7 valence electrons. I do not need any double or triple bonds because it all works out perfectly. Fluorine's happy, carbon's happy, hydrogen's happy. This is important. This hydrogen pulls electrons this way, but it's canceled out by that pull on the other side. However, fluorine is more electronegative than hydrogen. So it will pull electrons a lot that way, with hydrogen only pulling a little up. So it is polar because down here the fluorine is pulling it so much more. Think of this guy as a benching 500 pounds and able to tug a war like a madman, while this guy is an infant little child. Doesn't have a chance, so electrons are going to be pulled to the fluorine. Thus it is polar. Okay, SO2. SO2 is, start with sulfur, put my 6 valence electrons. Oops, I did 7. Okay, now I have 2 oxygens. The way I like to draw them is I like them on opposite sides, so I'll just take this lone pair and move the lone pair up there. So now I can put an oxygen over here. And oxygen has 6 itself. 1, 2, 3, 4, 5, 6. Then I also have an oxygen on this side. 1, 2, 3, 4, 5, 6. However, I have this lone pair right here and this lone pair right here. So it's going to have some resonance. So this will go right here. This will go right here. Form a double bond. And that's how you do that. Its shape, you will have, again, it has the linear shape. Bonded pairs, you just look for unbonded pairs. 1, 2, 3, 4. So you have 4 unbonded pairs. You have 1, 2, 3 bonded pairs. The shape is linear. And it is non-polar because the oxygens are going to pull it to both sides and they will cancel out. This is a lot of what we did today in class. I hope this helps. Again, C2H2, we did this in class. You should be a pro at this one. The C will, when it's C2H2, there will always be a double bond right there. But let's set it up. You start over here. with one of the carbons, do your 4, then do another with carbon. Then you have your hydrogen over here, hydrogen over here, but you have those 2 lone pairs, so this one will drop here. Sorry, wrong way. This will go here, this will go here, so you are left with that. Just like up there, it is non-polar because both sides are equal. They have the same structure on both sides, so the pull isn't anywhere. Okay, this is how you write the charges. You put the whole thing in brackets. I know a couple of you guys had trouble today. Put the whole thing in brackets. Again, just do it like the same, except worry about the brackets at the end. Remember, we have 3 extra electrons. So put phosphorus in the middle. Phosphorus has 5 valence electrons. 1, 2, 3, 4, 5. Then you put oxygen. 1 on this side, 1 on this side, 1 on this side, then 1 over here. And then it's -3, so we have to keep in mind we have 3 extra electrons. Oxygen has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that was there to begin with, so it looks like that. Then come here. 1, 2, 3. -3 charge, so we are perfectly happy. We can all get along. So that's why the polyatomic ions have these charges. They make the whole compound more stable. And 2, you just do put nitrogen here. 5, 1, 2, 3, 4, 5. Nitrogen over here. 1, 2, 3, 4, 5. But however, I'm not happy. My nitrogen over here only has 1, 2, 3, 4, 5, 6 on each side. So I need at least a double bond. So let me move this one and this one. So you have to kind of keep track. However, now I have 6, 7. I'm still not happy, and I still have 1 lone pair each, so I'm going to actually have a triple bond with 1 lone pair, 1 lone pair. Again, bonded pairs, I have 3 bonded pairs. I have 2 unbonded pairs because on the 2 sides, shape is shape is linear because it's linear. And will it be polar or non-polar? It will be non-polar because the pull is equal on both sides. So put N2 is non-polar. Write this down to turn into class. This is number 3 to write down. And that is the end. Thank you for watching this and be ready for class.